Okay, question number 8. I've got this curve with this restricted domain, not inclusive, that's why it's an open circle, goes through the origin. Okay, so as a minimum point at A, find the coordinates of Q, which is the minimum point. So I need to take the derivative and set it equal to 0. So I've got a product rule happening here. U equals X, U dash equals 1, V equals log by C of X, V dash equals 1 on X. So F dash of X is going to be the cross product. That times that, X times 1 on X, plus 1 times log by C of X. Therefore, 1 plus log by C of X is the derivative. And it's going to be at this point here when the derivative equals 0. So 0 equals 1 plus log by C of X. Log by C of X equals negative 1. Turn it into an exponential, X equals e to the negative 1, or 1 on e. So that's going to be at 1 on e. The coordinates of P, Q at the moment, I've got 1 on e is the X coordinate. I need to find the Y coordinate, so I want to put F of 1 on e back into the function, and this is my function. So 1 on e times log base e of 1 on e. 1 on e, I'd like to turn this into e itself. So it's log base e of e to the negative 1, which is going to be 1 on e times negative 1, so negative 1 on e. So negative 1 on e are the coordinates of Q. That's part A done. Part B says, using this derivative, find an antiderivative of this. So I'm going to be, or show that this has an antiderivative, Okay, so this is a showing. So I've got to show that the antiderivative of x log by c of x equals x squared log by c of x on 2 minus x squared on 4. That's what I've shown. And I'm going to use this to do it. So, if d dx of x squared log by c of x equals 2x log by c of x plus x, therefore x squared log by c of x is the antiderivative of 2x log by c of x dx plus the antiderivative of x dx, which is x squared on 2. Therefore, the antiderivative of 2x log by c of x dx should equal this. Therefore, the integral of 2x, of this bit here, log by c of x equals x squared log by c of x minus x squared on 2, and that's exactly what I had to show. Beautiful. Why did I do all this? So that I can use it in the next part of the question, which is find the area of the region that is bound by F, the line x equals A, and the horizontal axis of x between A and B. So we're looking for that area there between A and B on the x-axis. And I know that that's 1 on E, and I need to find B, and that's when this equals 0. So finding x-intercepts. 0 equals x log by c of x. That will be the case when x equals 0, or log by c of x equals 0, therefore x equals 1. So I know that that coordinate there is 1. So what is this area? This area will be the integral negative of 1 on e to 1 of x log by c of x dx. And the last question showed me that the integral of 2x log by c of x is equal to all of this. So I'd like to use half of that. So it's going to equal negative x squared on 2 log by c of x minus x squared on 4 from 1 on e to 1. So using the information given in the first part of the question, equals negative. If I put in 1, I'll have a half log base e of 1 minus a quarter. Then I put in my 1 on e minus 1 on e squared times a half log base e of 1 on e, and then plus 1 on e squared times a quarter. And that's going to equal negative, that's 0. So we've got negative a quarter, and this is going to be negative 1 on 2e squared, the 2's in the bottom, the e squared's in the bottom, negative log base e of e, which is negative 1, and then plus 1 on 4e squared equals negative 1 on a quarter, that's negative 1, so plus 1 on 2e squared plus 1 on 4e squared. So I get 1 quarter minus 2 on 4e squared, negative, so that's minus 3. Form that I was supposed to give the answer in? No, that's good.